Okay. Continuation of the topic Z transform. Last class I have given introduction about Z transform. So as I told earlier, in any continuous signal, a periodic waveform, any periodic analog signal, we can find the Fourier series. The Fourier series spectrum is a discrete version and non-periodic. Similarly, if the signal is non-periodic, its Fourier transform is a continuous function of omega, which is again non-periodic. To overcome the drawback of Fourier transform, what is the drawback of Fourier transform is, if any signal f of t is converge, directly we can find Fourier transform. If it is diverge, directly or indirectly we cannot find Fourier transform. If it is constant, indirectly we can find the Fourier transform. So any diverged signal, by multiplying with e power minus sigma t, as long as sigma greater than a, the resultant function become converge, then Laplace transform exists. So any diverged signal, Fourier transform not possible, Laplace transform is possible. This is what discussed previous class. The existent condition for Fourier transform is, whatever condition I told, it is sufficient, not necessary. It is sufficient, not necessary. I told reverse last class. There is a small correction. It is sufficient, not necessary. The same way, any discrete signal, also we can find Fourier series. So discrete time Fourier series, which is again discrete and periodic. Discrete and periodic. And Fourier transform of discrete sequence DTFT is again periodic but continuous function of omega. Again, if sequence is diverge, Fourier transform not possible. Again we multiply with the extra term r to the power of minus n, then it will become converge signal, then integral summation exists, that will become Z transform. So to overcome the drawback of DTFT, we go for the Fourier transform, Z transform. So this is the conclusions we have done last class. So continuation, how to get Z transform, existent condition for Z transform, inverse Z transform, then how to solve the problems in Z transform, inverse Z transform. So that kind of things we will study today. So if I start with DTFT, discrete time Fourier transform is x e power j omega. We can also call it as x of omega, which is equal to sigma x of n e power minus j omega n. N is changing from minus infinite to plus infinite. So this is the formula, discrete time Fourier transform. Now if this x of n is diverge, if it is diverge, what we do, multiply x of n with r power minus n. So when I am multiplying x of n with r power minus n e power minus j omega n. So that this will become converge. If this is converge, If this product is converged, summation is finite, we can answer. Further, we can simplify n equal to minus infinite to infinite, x of n r e power j omega minus n, r e power j omega minus n. Now let r e power j omega is z. Then this is changed to sigma n equal to minus infinite to plus infinite, x of n z to the power of minus n, z to the power of minus n. So same Fourier transform, change it to this. Now previously it is function of omega, now it is function of z. Now this I am calling as x of z. So this is z transform formula. This is formula for Z transform. Z transform is nothing but discrete time Fourier transform of x of n r power minus n. Z transform is nothing but Fourier transform of x of n r power minus n. Laplace transform is nothing but Fourier transform of f of t e power minus sigma t, both are same. So here we are replacing always z with r e power j omega. Now to find out inverse, what is the inverse is basically x of z equal to sigma n equal to minus infinite to infinite. This I am writing x of n r power minus n e power minus j omega n. Same, this I am writing here. Now I want x of n r power minus n. This is nothing but integral x of z, then e power, it is by na, so j omega n, or when it is x of omega, x of anything, alright. Okay, even if it is x of z. So here it is d omega, or otherwise make it to omega, this also omega. So this term is here. Now from this, what is x of n? And here you will get 1 by 2 pi. And it is a periodic 0 to 2 pi. Now from this x of n is 1 by 2 pi 0 to 2 pi x of omega, and here coming to r power n e power j omega n d omega, which is 1 by 2 pi 0 to 2 pi x of omega. Then what is this product is? This product is z power n. Z power n and d omega. What is d omega? Differentiate here. R and j e power j omega d omega equal to dz. So what is d omega? Is dz by r here j e power j omega. So this is further 1 by 2 pi j integral x of omega, this is again z, so it will become, this is also function of z, so I can write x of z also, then z power n minus 1 dz. Previously d omega, now it is changed to dz. It's a function of z, so x of z. This is I inverse z transform. This is inverse z transform. So z transform formula, inverse z transform formula. Because it here x of omega is a periodic signal, periodicity is 2 pi, so 0 to 2 pi. When it is changing to z domain, it will become like a contour. So we'll write a circle, it's like a closed, because z plane is a closed. Basically z equal to what? R e power j omega. If r is equal to 1, mod z is equal to 1, because mod of e power j omega is 1. But this omega is changing from 0 to 2 pi. So it will form a unit circle. It will form a unit circle 1 minus 1. So it is a z plane. Omega is changing from 0 to 2 pi. So 0 to 2 pi it will form a circle. Circle radius is 1. If z equal to r e power j omega, then circle radius become r. So radius is decided by r value, and e power j omega is a rotation. Omega is a digital frequency. Omega is a digital frequency changing from 0 to 2 pi. So now you got the formula for z transform and inverse z transform. So remember this, in analog t is what? Time period. And f is the frequency. Cycles per second. Omega is also frequency, but radians per second. Radians per second. And omega equal to 2 pi f. And this f equal to 1 by t, or t equal to 1 by f. So you are already familiar with this. But in digital, this t is sampling period, sampling duration, whereas capital N is the period. This t is a period, this n is also period. Now this omega, people want to use same omega here, but this omega is radians per sample. So when we are using same omega, this omega change it to ohm. Change it to ohm. Change it to ohm. So previously omega is radians per second, now ohm is the radians per second. This omega is used here, radians per sample. This small f is also changed with the capital F. Capital F is now cycles per second. So therefore ohm is equal to now 2 pi capital F. So in analog now ohm is used. In place of this f is used. This small f, this omega is now used for digital domain. So what is this f now? Cycles per sample. Cycles per second, cycles per sample, radians per second, radians per sample. So this is the notation. So whenever I am using omega, it is in digital domain. Whenever I am using ohm, it is the analog domain, meaning of radians per second. So this is a digital frequency. Analog frequency range is minus infinite to plus infinite in terms of spectrum, but realistic 0 to infinite. Whereas here digital frequency is changing from 0 to 2 pi, that's why it will form a circle. If you understand the concept of S-plane, S-plane is nothing but a complex plane. So any complex plane, what is S value? Sigma plus j omega. So this is real, this is j omega. I am talking S-plane means analog. Okay. So in Z-plane, circle. So this j omega line is mapped to this circle. LHS mapped to inside, this is LHS. RHS is mapped to outside. So this entire outside is, this RHS point is mapped to outside, this LHS is mapped to inside, left side is a stable portion, right side is a unstable, this is unstable, inside one is stable. This is S plane, this is Z plane. Okay. So just a brief idea. Next, existent condition for Z transform. Existent condition for Z transform. This we got from this only, na? Let me give another step here. Existent condition. What is existent condition? Minus infinite to infinite, x of n, r power minus n, e power minus j omega n. So this magnitude should be finite. This magnitude should be finite. So when this magnitude is finite, this is anyway finite, e power minus j omega n magnitude is anyway 1. So mod x n r power minus n, this magnitude summation, if it is finite, then Z transform exists. So what is the condition for Z transform? Summation from minus infinite to infinite, mod x of n z power minus n should be finite. What is the existent condition for Fourier transform? Minus infinite to infinite, mod x of n should be finite. So that is only the difference. Next to problems. X of n is a power n u of n. Find Z transform. So in this topic, x of n will be given, find Z transform, or x of z will be given, find x of n. So what is x of z formula? So a power n u of n, this is x of n, z power minus n. U of n is a unit step. So this is existing only right side. Therefore n equal to 0 to infinite, a power n z power minus n. n equal to 0 to infinite a z inverse to the power of n. So as per the mathematics, you know this, x power n is equal to 1 by 1 minus x if x less than 1. If n is changing from 0 to infinite, if x less than 1, this is simplified to 1 by 1 minus x. So same way, 1 minus a z inverse provided a z inverse is less than 1. If you simplify this, you will get z by z minus a. Then what is this condition? A less than z. That means mod z greater than mod a. This is ROC. So as long as mod z greater than mod a and this is converge, you will get answer z by z minus a. This is the answer. Next problem. Minus a power n u of minus n minus 1. So x of z is sigma n equal to minus infinite to plus infinite minus a power n u of minus n minus 1 z power minus n. So this is existing from u of minus n minus 1 is existing from minus 1 to minus infinite. So basic signal operations, you should aware of it. First operation is shifting. Shifting can be right, shifting can be left. Shifting is one of the operation. Second one, compression or expansion. Sorry, you can amplify or attenuate. Vertically you can amplify or attenuate. This is the second operation. Horizontally you can expand, compress. This is a scaling. Scaling in time domain. It is like f of at. Then fourth one, folding. You can fold right to left or left to right or upper to bottom, bottom to upper side. So this is folding. So shifting is one operation, scaling, then amplification or attenuation, then folding. These are the four operations. So keeping that in mind, it is similar to u of minus t minus 1. So minus t minus 1 greater than 0, then only it will be 1. So minus t greater than 1. So t less than minus 1. So as long as t less than minus 1, this value become 1. Means from minus 1 to minus infinite. So therefore this is sigma n equal to minus 1 to minus infinite, minus 1 to minus infinite, minus a power n, minus a power n, z power minus n. This is sigma n equal to 1 to infinite minus a z. So minus I am changing to plus. Then this will be a z inverse, a inverse z to the power of n. Okay. This I am changing plus. So z power n, here it is already plus there, a power minus 1. This is further we came, but here 1 to infinite. So 1 minus sigma n equal to 0 to infinite a inverse z to the power of n. This we can simplify. So 1 minus 1 by 1 minus a inverse z provided if a inverse z less than 1. A inverse z less than 1 means mod z less than mod a. Mod z less than mod a, this is ROC. But if you simplify this, you will get same answer z by z minus a. So what is the important point you can observe? A power n u of n z transform is z by z minus a minus a power n u of minus n minus 1 z transform also z by z minus a. If this is given, inverse will be this or this. So this or this is decided based on ROC. If ROC given less than a, you have to give this answer. If ROC greater than a, then you have to answer this. So that is important point. So previous case mod z greater than a. Let me explain ROC concept. What is the example you have taken? X of n is a power n u of n. If a less than 1, if a less than 1 is 0.5, so 0.5 to the power of 0. So how the sequence will be? 0.5 to the power of 0 is 0.5. 0.5 to the power of 0 is 1. Next to 0.5. Then 0.25 and so on. Like this it will come. It is converging. If a less than 1, converge. So how the ROC will be? Unit circle, but a less than 1 I am taking 0.5. This 1, this 0.5. So what is ROC? Mod z greater than a. So greater than a means this. So this is ROC. So this unit circle is present in ROC. So when unit circle is present in ROC, Fourier transform also exists. Fourier transform, Z transform same. Fourier transform, Z transform same. But if a greater than 1, this is unit circle. So a greater than 1, I am taking some 1.5. So it will be outer circle. This is 1.5. So what is mod z greater than a? This is ROC. But this unit circle not in ROC. That means what? Z transform is possible, Fourier transform not possible. They are not same. So if unit circle is present in ROC, both are possible. If unit circle not present in ROC, Z transform only possible, Fourier transform not possible, because if a equal to 1.5 to the power of 0, 1.5 to the power of 1, 1.5 to the power of 2, so its sequence will be diverge. So any diverge signal, Fourier transform not possible, but Z transform is possible. Because it is already converge, so Fourier transform, Z transform both are possible. So that is the significance of A. So I have given both the examples just to understand converge and diverge. The same thing you can verify in this example also. Choose A value less than 1 or greater than 1. but here condition is mod Z less than A. So what is the rule? Unit circle should be in ROC, then Z transform, Fourier transform remain same, otherwise they are not equal. Another problem, x of n is 1 by to the power of n u of n plus 2 power n u of n. So this is a right side, this is also right side. So what is x of z here? 1 by 1 minus 1 by 2, this is a value, z power minus 1 plus 1 by 1 minus a, so 2 z inverse. But what is ROC in this case? Mod z greater than 1 by 2, whereas here mod z greater than 2. So one function greater than 2, other greater than half. So finally x of z ROC is what? Mod z greater than 2. So if I take mod z greater than 2, this condition is satisfied, this condition is also satisfied. So this you have to simplify. The final answer is 2 minus 5 by 2 z inverse by 1 minus 5 by 2 z inverse plus z power minus 2 and mod z greater than 2. This is the answer. With the numericals we worked out. So for a right sided and of infinite duration, u of n is an infinite duration signal, the ROC is the region in the z plane outside the outermost pole. ROC is outside the outermost pole. So outermost pole is this, so it is greater than 2, outside the outermost pole. So if you locate poles, 2 poles will be there, but ROC will be greater than outermost pole. That is the concept or a statement. Or another example, minus 1 by 2 u of minus n minus 1 2 power n u of minus n minus 1. So here left side, what is x of z? Here what is the answer? Minus a power n u of minus n minus 1 is what? 1 by 1 minus 1 by 2 z inverse. 1 by 2 z inverse. And here it is plus is there, minus of minus. So this is minus 1 by 1 minus 2 z inverse. But here mod z less than 1 by 2, here mod z less than 2. Mod z less than 1 by 2, mod z less than 2. So what is the final answer when you are simplifying? This answer is minus 3 by 2 z power minus 1 by 1 minus 5 by 2 mod z less than 2. So here mod z less than 2, mod z less than half less than 2. So to satisfy both the conditions, mod z less than 1 by 2. Less than 1 by 2. So less than 1 by 2 itself less than 2. So both the conditions are satisfied. So for a left side sequence, ROC will be less than lower pole. Lower pole is this. So that is the ROC concept. So with this I will stop. So we understand, we derived Z transform formula, inverse Z transform formula, existent condition for Fourier transform as well as Z transform. Then what are the notations in analog domain, notation in digital domain. Then we solved problems how to find Z transform. We will continue next class with some more problems. Thank you.